Bearings are machine parts in which other parts turn or slide. In general, their purpose is to help moving parts operate efficiently. Almost every type of moving machinery uses bearings. Anyone who is responsible for maintaining moving equipment needs to know how bearings operate and how to check bearing performance. Maintenance personnel also need to know how to remove worn or damaged bearings and install new bearings. Two general categories of bearings are rolling contact bearings and sliding surface bearings. This unit focuses on sliding surface bearings. Bearings are found in almost every type of moving machinery, and they perform three basic functions. They reduce friction, they position moving machine parts, and they carry load. The term load refers to the force or weight that is placed on a bearing. Different bearings are designed to withstand different types of loads. Most sliding surface bearings are mounted on rotating shafts, and the type of load that is placed on the bearing is determined by the direction in which force is applied in relation to the shaft. In these terms, load can be either axial or radial. Radial load is applied along a radius of the shaft. A radius is a line from the center line of the shaft to the outside of the shaft. Axial load is applied along the center line or axis of the shaft. Axial loads are sometimes referred to as thrust loads. Sliding surface bearings are often divided into two basic categories based on the type of load that specific bearings are generally designed to handle. The two categories are journal bearings and thrust bearings. Journal bearings are generally designed to handle radial load, and thrust bearings are generally designed to handle axial load. Let's look at journal bearings first. A journal bearing is the simplest type of bearing because it has just one part, the bearing itself. The bearing is the cylindrical part that surrounds and supports the shaft. The term journal does not refer to a part of the bearing. The journal is the place on the shaft that is surrounded and supported by the bearing. Two basic types of journal bearings are solid bearings and split bearings. Here are two examples of solid journal bearings. A solid journal bearing is sometimes called a bushing or a sleeve bearing, depending on its thickness. A bushing is a solid cylinder of relatively thin metal that receives most of its strength from the housing in which it is mounted. The term sleeve bearing usually refers to a thick-walled type of solid journal bearing. This is an example of a split journal bearing. This bearing is bonded to its housing. The bearing and the housing can be split into halves, so it is relatively easy to remove them from the shaft to examine or repair them. Journal bearings are generally designed to handle radial loads, and thrust bearings are designed primarily to handle axial or thrust loads. Thrust bearings are generally used in pairs. One bearing is placed on either side of a thrust collar. The thrust collar is a solid metal disc that may be a separate part attached to the shaft or an integral part of the shaft. The two thrust bearings support axial load in both directions on the shaft. We'll look at two general types of thrust bearings, flat land bearings and tilting pad bearings. This flat land bearing is one of the simplest types of thrust bearings. It is a solid piece with no movable parts. Grooves in the bearing divided into sections called lands. This bearing is a tilting pad thrust bearing. It's also called a Kingsbury thrust bearing. A typical tilting pad bearing has two main parts, movable thrust shoes and a support bracket. The thrust shoes are pivoted to allow them to move slightly. The thrust shoes rest on the support bracket. They're held in place by pins on the support bracket that fit into holes on the back of the thrust shoes. The material that is most commonly used to make sliding surface bearings is Babbitt. Babbitt is an alloy made of three metals, tin, antimony, and copper. The actual amount of each metal that is put into the material varies according to the way that the bearing is to be used. Babbitt is relatively soft, so it is always bonded to a shell that is made of a stronger metal, such as iron or steel. if it is intended to support a heavy load. Babbitt is a very useful bearing material because it has all of the properties that a bearing material should have. Two other metal alloys that are commonly used to make bearings are bronze and brass. Bronze is made of copper and tin, and brass is made of copper and zinc. Bearings can also be made of non-metallic materials. For instance, this bearing is made of a type of plastic called phenolic. A major function of bearings is to reduce friction. Friction is the resistance to motion that occurs whenever one surface moves over another. In sliding surface bearings, friction is reduced by a process called film lubrication. Film lubrication is a process in which a film of lubricant is distributed and maintained between the bearing and the shaft as the shaft rotates. Lubricant stored in the bearing housing is picked up by the spinning shaft and pulled between the surfaces of the bearing and the shaft, where it forms a film. As the shaft rotates, it floats on this film of lubricant, so there is no metal-to-metal contact between the shaft and the bearing. If the film of lubricant were not present, the shaft and the bearing would contact each other and wear out rapidly. The film of lubricant also increases the amount of load that the bearing is able to support, because it distributes the load over a greater area of the bearing surface. Sliding surface bearings are usually lubricated with oil. One common oil lubrication system is an oil ring system. In this system, a ring rests directly on the shaft. The lower half of the ring is submerged in oil in a reservoir located in the lower half of the bearing housing. As the shaft rotates, the oil ring turns, carrying oil from the reservoir up to the top of the shaft. The oil spreads across the shaft, and any excess runs back down into the reservoir. In a piece of operating equipment, as the shaft continues to turn, a continuous film of lubricant forms between the bearing and the shaft. Another type of oil lubrication system for sliding surface bearings is a force feed system. This type of lubrication system is used when a pressurized feed to the bearing is required or when it is necessary to keep the oil filtered and cool. In a typical force feed system, oil is stored in a reservoir that is separate from the bearing. A pump forces the oil into the bearing. After the oil has passed through the bearing, it is collected in the reservoir so that it can be pumped again. Oil filters are often used in force feed systems to keep the oil clean. Filters remove dirt from the circulating oil. Many force feed lubrication systems also use oil coolers. Coolers remove heat that the oil picks up from the bearing. Grease is occasionally used to lubricate some sliding surface bearings. When grease is used, it is generally pumped into the bearing with a grease gun. The grease is pumped through a grease fitting located on the housing. Check your plant's procedures to see how often bearings should be greased and how much grease to use. In any case, it is important to keep the lubricant free of contaminants and to make sure that the lubricant stays in the bearing. Most sliding surface bearings use shaft seals to keep the lubricant in the bearing and dirt and grit out. Two common types of shaft seals are contact seals and labyrinth seals. Contact seals are generally fixed to the bearing housing. They rub against the shaft as it rotates. Contact seals are made of soft materials, such as rubber or felt, so that they will not damage the shaft. Labyrinth seals are usually made of metal. A labyrinth seal comes in two parts. One part is attached to the shaft and rotates with it. The rotating part fits into a fixed part that is attached to the bearing housing. The two rings that make up the seal are ridged. The ridges force any leakage to follow a long bending path that prevents oil from leaking out and outside contaminants from getting into the bearing. In this part, we've seen what film lubrication is, and we've seen different ways that bearings can be lubricated. Now try a question on this material. In this topic, we looked at types of sliding surface bearings, And we saw how sliding surface bearings can be lubricated. Now is a good time to try some practice questions. Since your job involves maintaining equipment that uses bearings, it's important for you to be able to tell if a bearing is performing properly. There are three major indicators of bearing performance: temperature, vibration, and noise. Any of these three indicators can provide evidence of whether a bearing is functioning properly. We'll look at temperature first. A bearing doesn't reach its normal operating temperature until after the equipment has been operating for a while. The amount of time that's required varies with each piece of equipment. After a bearing reaches its normal operating temperature, the temperature should stay relatively constant unless there is a change in operating conditions or the bearing malfunctions. Changes in bearing temperature can occur for a number of reasons. However, a sudden increase in the operating temperature of a bearing that cannot be explained could indicate a serious problem, including the possibility that the bearing has failed. Carefully touching a bearing housing is the simplest and most often used method of estimating the operating temperature of the bearing inside. With experience, a mechanic can tell by feeling a bearing housing whether the bearing is running too hot. Although the temperature of the bearing housing is not identical to the temperature of the bearing, the two are related. An increase in the temperature of the bearing causes an increase in the temperature of the bearing housing. An abrupt change in the temperature of the housing could indicate a problem with the bearing. Another indication of bearing performance is vibration. A change in the vibration level may indicate abnormal bearing operation. However, it is often difficult to detect a change in vibration without the help of instruments unless the change is of major proportions. A major change in vibration can usually be both felt and heard. Vibration meters are often used to measure vibration. Some vibration meters are permanently installed in equipment, while others are portable. Vibration meters have probes that measure the frequency and intensity of the vibrations from a bearing housing or any other object against which they are placed. These measurements are then converted into readings that are seen on the meter's face or on a recorder. Noise is another indicator of bearing performance. Excessive noise typically indicates a problem. A sounding rod can be used to listen to a bearing to see if there are any rumbling or grinding sounds while the shaft is rotating. An experienced mechanic can tell the difference between the normal operating noise of a bearing and the operating noise of a bearing that is beginning to fail. The temperature of the oil should also be checked. This can be done with a thermometer. A higher than normal oil temperature indicates a problem with the bearing. A properly installed and maintained bearing can last for years, but eventually bearings fail. The three most common causes of sliding surface bearing failure are metal fatigue, improper lubrication, and misalignment. The term metal fatigue refers to the effect on metal of prolonged flexing and bending. All sliding surface bearings are subject to load and vibration, which cause the metal in the bearing to flex and bend. The metal is gradually weakened by the flexing and bending, and eventually the bearing fails. The bearing surface then breaks up and becomes rough. This roughened surface causes an increase in the bearing's operating temperature and an increase in vibration. Another cause of sliding surface bearing failure is improper lubrication. Improper lubrication refers to three different situations: too little lubricant, contaminated lubricant, and the wrong kind of lubricant. Too little lubricant can prevent the formation of the lubricant film that's required between the bearing and the shaft. If this film is not present, contact between the shaft and the bearing will cause the bearing to wear out and fail. Sometimes small pieces of the bearing metal will stick to the shaft. This condition is called wiping because the shaft wipes away pieces of the bearing surface. Wiping produces grooves in the bearing surface. Contaminants in the lubricant can also cause problems. A liquid contaminant, such as water, can alter the properties of the lubricant, and adversely affect the lubrication process. Solid contaminants, dirt for instance, get pressed between the bearing and the shaft, where they can cause damage to both parts. Using the wrong kind of lubricant also affects the creation of the film of lubricant between the bearing and the shaft. The lubricant in a particular sliding surface bearing must have the right properties for that bearing. Misalignment is another cause of sliding surface bearing failure. Misalignment occurs when the shaft does not pass through the bearing squarely. If the bearing is misaligned, the shaft rubs against one side of the bearing at one end and against the opposite side of the bearing at the other end. If the shaft rubs against the bearing, it wears away the film of lubricant between the bearing and the shaft, thus increasing friction. If the rubbing continues, there are two additional effects. The temperature of the bearing rises because of increased friction, and the bearing material wears away rapidly from the continuous contact with the shaft. The increased operating temperature can also cause other problems in the bearing that may result in failure. The lubricant in the bearing could break down, or the metal in the bearing could melt. In this topic, we looked at common indications of bearing performance and the instruments used to measure these indications. We also looked at causes of sliding surface bearing failure. Now try some practice questions on this material. In order to perform properly, bearings must be kept in good operating condition. In this part, we'll look at a maintenance procedure for a split journal bearing on a water feed pump. We'll see how to disassemble the bearing, inspect it, and then reassemble it. This pump contains two thrust bearings in addition to the journal bearing. Plant procedures require all bearings in the pump to be serviced at the same time, but we'll focus on the journal bearing. The bearing surfaces for this particular journal bearing are in the form of two removable inserts. This feed pump has been locked out, tagged, and isolated from the system. The pump has also been drained of fluid. To begin, the mechanic removes the bolts from the top half of the bearing housing. Then he removes the guide pins that help align the two halves of the housing. After all the bolts and the guide pins have been removed, the mechanic removes the top half of the housing and sets it aside. In this example, the thrust bearings are removed first before the journal bearing is disassembled. Once the thrust bearings have been removed, the mechanic removes the bolts that hold the two shells of the journal bearing together. He then removes the upper shell of the journal bearing from the shaft. In order to remove the lower bearing shell, the shaft must be raised slightly to take the weight off of the lower shell. While the shaft is raised, the mechanic slides the lower bearing shell around the shaft and removes it. After the bearing has been removed, the shaft is inspected for high spots, scoring, or discoloration. If there is deep scoring, the shaft should be remachined or replaced. After the mechanic inspects the shaft, he inspects the bearing inserts. He pays particular attention to the lower insert because it typically bears more load. He checks the inserts for scoring, high spots, wiping, or discoloration. The bearing inserts are a matched set. This means that if one insert has to be replaced, then both are replaced. After the bearing has been thoroughly inspected and any necessary maintenance has been performed, the bearing can be reinstalled. When this is done, it's important to make sure that the bearing is properly fitted to the shaft. One way to do this is to check the clearance between the bearing and the shaft. The mechanic will use a micrometer and a T-gauge to check the total clearance. First, the mechanic measures the diameter of the shaft with the micrometer. Then he positions the T-gauge inside the bearing. The mechanic sets the T-gauge to the distance of the inside diameter of the bearing, and then he measures the T-gauge with the micrometer. To obtain the total clearance, the mechanic subtracts the diameter of the shaft from the inside diameter of the bearing. If the total clearance is too great, the bearing inserts are replaced and the test is repeated. If there is too little clearance, the bearing is either replaced with a bearing of the correct size or else it is scraped down. After the clearance check is made, the journal bearing is ready for reassembly. The lower shell of the bearing is installed first, and then the mechanic puts the upper shell in place. Once the bearing shells are properly positioned, the mechanic installs the bolts that hold the shells together. Next, the thrust bearings are installed on the shaft. Then the bearing housing is reassembled, and the housing bolts and guide pins that secure and align the housing are installed. Finally, the mechanic tightens the housing bolts, following a pattern specified by the manufacturer to make sure that they are tightened evenly. In this part, we'll look at a maintenance procedure for tilting pad thrust bearings. We'll see how to take a thrust reading, and we'll see how to disassemble, inspect, and reassemble a thrust bearing. This water feed pump contains a journal bearing and two thrust bearings. There's an inboard thrust bearing and an outboard thrust bearing. The thrust bearings are mounted on either side of a thrust collar. Each thrust bearing assembly includes thrust shoes and an upper and lower support bracket. The pump has been locked and tagged out according to company procedures. It has also been drained of fluid. Typically, the first step in thrust bearing maintenance is to take a thrust reading to measure total clearance. The total clearance for a thrust bearing is the amount of thrust collar movement that is allowed by the thrust shoes and the support brackets. Thrust readings can be taken with feeler gauges or wedge gauges, but these mechanics will use a dial indicator. One mechanic removes an access plug from the end plate of the housing and sets up the dial indicator to contact the end of the shaft. He secures the dial indicator to the end plate so that it will not slip as the reading is taken. When the dial indicator is in position, the other mechanic moves the shaft as far as it will go in one direction. The dial indicator is then set to 0. Next, the mechanic moves the shaft as far as it will go in the opposite direction, and the thrust reading is taken. The value shown on the dial indicator is compared with the value given in the manufacturer's specifications. If the reading on the dial indicator is higher than the total clearance specified by the manufacturer, the clearance is excessive and maintenance is required. To check the reading, the mechanic moves the shaft back in the other direction to see if the dial indicator returns to 0. If the dial indicator does not return to 0, the indicator may have slipped and the reading should be taken again. Worn-out thrust shoes are a common cause of excessive clearance in a thrust bearing. However, the only way to determine the exact cause of the excessive clearance is to disassemble the bearing and inspect the shoes. Before starting the disassembly, the mechanic cleans the outside of the bearing housing to lessen the chance of dirt or grit getting into the bearing and causing damage. The mechanic removes the end plate and the housing bolts and guide pins. He then removes the top half of the bearing housing. The outboard thrust bearing is removed first. The mechanic begins by removing the thrust shoes. The thrust shoes are placed on a clean work surface to prevent them from collecting dirt. Then the support brackets are removed. They are also placed on a clean work surface. Once the outboard thrust bearing is completely removed, the process is repeated to remove the inboard thrust bearing. After both thrust bearings are removed, the next step is to inspect the thrust collar. The mechanic inspects the thrust shoes next. He removes each shoe from the outboard bearing and carefully inspects it for signs of excessive wear. If any shoe in this type of bearing shows signs of excessive wear, the entire set of shoes must be replaced. If only one or two shoes were replaced, the new shoes would be thicker than the old shoes and more load would be placed on the thicker new shoes. As a result, the new shoes would wear out more rapidly than they would if the whole set were replaced. The thrust shoes in this bearing are in good condition. They show no signs of excessive wear, so they will not be replaced. After checking the shoes, The mechanic is careful to replace them in their original positions. The mechanic checks the thrust shoes and the inboard bearing in the same way. Now let's watch the mechanic reassemble the bearing. The inboard bearing is installed first. The mechanic starts by installing the inboard support brackets on the shaft. Next, the mechanic carefully installs the thrust shoes in their original order. Then the mechanic positions the inboard bearing with the locking pin groove at the top. Next, the outboard bearing support brackets and thrust shoes are installed. To make sure that the bearing components won't slide off the shaft, the mechanic carefully holds the support brackets in place as he installs the thrust shoes. When the outboard bearing is completely assembled, the mechanic rotates the outboard bearing until the locking pin groove is properly aligned with the groove on the inboard bearing. The locking pin grooves must be positioned properly to allow the locking pins to fit into the grooves when the bearing housing is installed. The locking pins hold the thrust bearings in place so that they don't spin with the shaft. Finally, the bearing housing is reassembled. The upper half of the housing is put in position. The bearing housing bolts are installed next, and then the guide pins that align the housing are tapped into place. Following company procedures, the mechanic tightens the bolts in a specific pattern to ensure that they are tightened evenly. In this topic, we looked at maintenance procedures for a split journal bearing and a tilting pad thrust bearing. Now check your understanding of the material by trying a couple of practice questions.